Hello and welcome. In this video, we are discussing incidence matrix, which is part of graph theory. Incidence matrix is that matrix which represents the graph such that with the help of the matrix, we can draw the graph. This matrix can be denoted as a capital A and A. This means if only incidence matrix is given, you should be able to draw a graph. What information we will get from this incident matrix? This matrix tells which branch are incident on which node, at which node, and what are its orientation. Means what is the direction of the current flows, whether it is towards the node or away from the node, and this branch incident on or between which two nodes. What is dimension of this matrix? How many number of rows and columns included in this incident matrix? The number of rows, it related to the number of nodes. If there are n number of nodes in your graph, there are n number of rows. And number of columns is related to the branches in your graph. If there are b number of branches, your columns in your matrix are b. What are the elements of this incident matrix? The elements of this incident matrix are -1, 0 and +1. Now when it is +1, -1 and 0. 1, if the branch J incident at node I and its orientation is away from the node I. This is important. When it is -1, if branch J is incident on node I and its orientation is towards the node. And when it is 0, if branch J is not incident at node I. We'll understand this when we'll actually draw or write the incident matrix. One more point you need to remember. Graph theory, we have started to analyze the electrical network. So this matrix always analogous to the KCL, Kirchhoff current law, which we are going to use this matrix for network analysis. Now let's draw or write the incident matrix for this graph. We already know how to draw the graph for any particular network. So please watch previous video so that you can understand how this graph comes. Now here in this graph there are how many nodes? 1, 2, 3, 4 and 5 nodes. Means number of rows in your incident matrix will be 5 for this graph. Number of branches, instead of 1, 2, 3, for differentiating I have marked it as a ABCD. But you can mark it as a 1, 2, 3 or ABCD according to your convenience. So this graph is related to this circuit. We already studied this. You can watch the previous video. Now for this graph, let's write incident matrix capital A. Number of columns is equal to number of branches and number of rows is equal to number of nodes. Now this incident matrix tells us which branch incident at which nodes. Always for a branch, one branch, there are two nodes related. Okay, and according to its orientation, we'll decide whether the current is towards the node and away from the node. Now let's see branch A. Branch A, it lies between node 1 and 2. Means only for node 1 and 2, the elements of the matrix is either 1 and -1. For others node, means this branch A doesn't incident on node 5, 3, 4. So for this 3, 4 and 5 node, element is 0. So for branch A, it incident at node 1 and 2. So this branch A incident at node 1 and 2. So only for these elements, it will be 1 or -1. How to decide 1 or -1? We know the rules. This one. 1 if branch J incident at node I and its orientation is away from the node I. Means see here, branch A, its orientation is away from the node 1. So for node 1 we have to write the element 1, and for node 2 orientation, this arrow is towards the node. So direction of flow of current is towards the node 2 and away from the node 1. So if the orientation is towards the node 2, its element is -1. And for other nodes 3, 4, 5, this branch A doesn't incident at node 3, 4 and 5. So for these three elements, your network element should be 0. Now let's go to the branch B. Branch B. Two nodes are included. Which one? 2 and 3. For other nodes, your branch B doesn't incident. So only for node 2, this row 2 and row 3, this row represent nodes. So node 2 and 3 has a element, yes, 1 and -1, depending upon the orientation of the current. Now branch B, it is current flows away from the node 3, means from node 3 for branch B and node 3 element should be 1 away from the node, and for node 2 this direction of current is towards the node 2, means branch B and node 2 element should be -1. Let's see. Similarly, you can easily do for branch C. Branch C, which node are included? Branch C incident at node 2 and 4. For node 2, orientation is away from the node 2. Means element for node 2 and branch C, it should be away from the node 2, means it is 1, and for node 4, it is towards the node 4. Node 4 and branch C, it is -1 towards the node. Similarly for D, D branches between node 1 and 4. For node 1, orientation is away from the node 1. Means away from the node means branch node 1 and branch D. What is the element? 1 away from the node 1. And branch D incident at node 4. Node 4 branch D towards the node 4 means it is -1. Similarly, you can figure out for E, branch E is between 3 and 4. So check the orientation and check the elements whether it is correct or not. Then F, branch F between node 1 and 5. Element 1 and -1 depends upon the orientation. What is this 1 indicate? Branch 1 incident at node 1 and its orientation is, element 1 means its orientation is away from the node 1. Then branch F, it incident at node 5 also, and its orientation is towards the node 5 because element is -1. Similarly for G. And for other elements, other remaining elements are all are 0 elements. So remember, for each column, each branch has a 2 nodes. So it can be either 1 and -1 for each column, and other element should be 0 because these branches doesn't incident at these nodes. That's why we are making other elements 0. So this is very easy to write the incident matrix for this particular graph or any graph. So incident matrix tells us which branch incident at which node. One more term which is very important related to this incident matrix is reduced incident matrix. If we have an incident matrix, any arbitrary row of this incident matrix, if we delete it, the new matrix is formed, and that is called a reduced incident matrix. That's it. So if there are n nodes in incident matrix, there are n rows. In reduced incident matrix, one row is less, that is n minus rows, n minus 1 rows are there. So this is our incident matrix. We have just formed it. Any one of the row you can delete, either 2, 3, 4, 5, any one of this row you can delete, and whatever the new matrix form is called as a reduced incident matrix. So if I will delete this row 5, this remaining incident matrix is called as a reduced incident matrix. Number of rows are 4 instead of 5, and branches remain same. So this is reduced incident matrix. Now, always there is a question related to this one, number of trees. In previous video, we know the concept of trees for particular graph. From this reduced incident matrix, we can find how many number of trees possible for the particular graph. It is A and A transpose. A is reduced incident matrix. So practice is take a network, draw its graph, and write its incident matrix and reduce the incident matrix. Thank you.